Welcome to the method of undetermined coefficients for nth order ODEs. So recall, we can use the method of undetermined coefficients for equations of the form let's go with a naught times the nth derivative of y plus a1 times the n minus first derivative plus all the way down to plus a sub ny equals, we have two options, or equals f of x, where f of x is either e to the lambda x times some polynomial b naught x to the k all the way down to b sub k, or f of x is e to the lambda x cosine omega x times polynomial plus e to the lambda x sine of omega x times a polynomial. Oops, a different polynomial. That should be a q of x. And then our guess for yp matches the form for f of x. Except we may need to multiply by a power of x. Where x to the j, where j is, I'm going to just shift this a little bit, sorry. Right, where j is the number of repetitions of r equals lambda, or r equals lambda plus or minus omega I as roots of the characteristic equation. So a little useful trick we have is that we can somewhat limit our amount of product rule we need to apply by getting rid of the e to the lambda x before we do the method of undetermined coefficients. So a useful trick is to eliminate the e to the lambda x before applying the method of undetermined coefficients. And the way to do this is to assume that y is u times e to the lambda x, and then rewrite the equation in terms of u. So for example, let's say that we want to find a particular solution to the third derivative of y plus 5 times the second derivative minus y prime minus 5y is equal to e to the 3x times 2x plus 1. So what we could do is we could go ahead and assume y is equal to e to the 3x times u. Then we have y prime is 3 e to the 3x times u plus e to the 3x times u prime. And the second derivative of y would be 9 e to the 3x times u plus 6 e to the 3x times u prime plus e to the 3x times u. So we would wind up with, oh, and the third derivative would be 18 e to the 27 e to the 3x times u. Then we would have 9 e to the 3x times u prime plus 18 e to the 3x times u prime. Sorry, this last one should have been a double prime in the previous row. So 9 e to the 3x times u prime plus 18 e to the 3x times u prime would give us plus 27 e to the 3x times u prime. Then we would have a 6 e to the 3x times u double prime plus a 3 e to the 3x times u double prime would be 9 e to the 3x times u double prime, and then plus e to the 3x times u triple prime. And so our equation becomes, I'm going to just pull an e to the 3x out of everything. We have a 27u plus 27u prime plus 9u double prime plus u triple prime. Then we have plus 5 times 9u plus 6u prime plus u double prime. Then we have minus 3u plus u prime, and then minus 5 times u. All of this is equal to e to the 3x times 2x plus 1. So we can go ahead and just cancel out that e to the 3x. We have u triple prime, or third derivative of u. Then we have a 9u double prime plus 5u double prime. So we have plus 13 second derivative of u. We have a 27u prime plus 30u prime minus u prime would be plus 56 u prime. And then we have plus 27u plus 45u minus 3u minus 5u. So that's 24u plus 40u is plus 64u is equal to 2x plus 1. Again, you don't need to do this if you don't want. This just avoids having to do the product rule with 2x plus 1, and we can just stick it with u's and u primes. At this point, if we do our sort of characteristic equation check, we have characteristic equation r cubed plus 13r squared plus 56r plus 64 equals 0. Our e to the lambda x is now e to the 0x. So we have lambda equals 0. R equals 0 is not a root, and so we're good. So we can go ahead and just guess that yp is just a first degree polynomial or a degree 1 polynomial. So we will guess yp is ax plus b. We have yp prime is just a. The second derivative is 0. And the third derivative is 0. So we wind up with 0 plus 13 times 0. Sorry, these should be UPs instead of YPs. So U sub P prime, U sub P double prime, and the third derivative of U sub P. We have 0 plus 13 times 0 plus 56 times A plus 64 times AX plus B should be equal to 2x plus 1. So we have that 64AX should match the 2x. So 64A should be equal to 2. And 56A plus 64B should match that 1. So 64A equaling 2 tells us that A should be equal to 1 over 32. And we are therefore looking at 56 over 32 plus 64b is equal to 1. 56 over 32, we could rewrite if we so choose as 7 over 4. So we have 7/4 plus 64b is equal to 1. That means 64b is equal to negative 3/4. And we get that b is equal to negative 3 over 4 times 64. We are looking at 256. So we get our u sub p is 1 over 32 times x minus 3 over 256. So our y sub p, well, it should just be u sub p times e to the 3x, right? So since y was u times e to the 3x, so y sub p is just u sub p times e to the 3x. We get y sub p is e to the 3x times 1 over 32x minus 3 over 256. Again, it's completely up to you if you want to just do your guess as e to the 3x times ax plus b, that's perfectly fine. And then you can just do all of the product rules with the x's involved as well. So this is our particular solution. I don't remember if we were asked, yes, that was as far as I asked you to go. We do not need to find the general solution. So at this point, we're done. We've found our particular solution. If we wanted to know our general solution, the third derivative of y plus 5 times the second derivative minus y prime minus 5y is easily factorable by factor by grouping. So we could find the general solution if we wished. But this is finding a particular solution using method of undetermined coefficients. Again, you can apply that trick or not. It is entirely up to you.